properties and applications. First, we visual the product contents. What is BC? Properties of BC. Roman for BC principles. Temperature cooling, evaporative cooling, determination of Bose temperature, correlation to counterintuitive phenomena, Bose number, superfluids, superconductivity, slower stationary lights. Then applications, detectors, cognizance, and atom classes and future and conclusions. First, we discuss what is BEC. When low density bosonic particles are hypercooled, the particles come together and act as a single atom. This superatom is called Bose-Einstein condensate. This condensate consists of particles in ground state. This phenomenon is a consequence of Bose-Einstein statistics. This statistics favors the residence of multiple particles in single quantum state. The properties of BC. These are supercooled atom-like entities which have well-defined amplitude and represented by a single wave function. A single phase constitution contains 10 to the power 7 condensed gas atoms. The condensed particles move in a similar fashion at the same time along the same direction. They exist only at temperature within a few billion of a degree, absolute zero. Pauli's principle does not apply to this assembly. They follow Bose-Einstein statistics. Next. Condensation. So what happens in condensation is the temperature is when we decrease temperature drastically drastically reduced atomic distance are imposed on the movement of the atoms. The free energy present in the region stripped up. So the group of atoms C's or condensate behave as a one entity. Only bosons and boson-like particles are fit for this process. As they do not obey Pauli's exclusion principle, so they can reside at a single quantum state. The extremely cool temperature is achieved by the processes like laser cooling and evaporative cooling, which could take the bosonic particles to nanokelvin temperature. Then laser cooling. In this process, the photons of a laser of certain wavelengths strike the atoms and get absorbed by them. The excited atoms then release these photons in accurate directions. So when this repeatedly happens, this sequence, the momentum atom will change and consequently decreases. Since the temperature of the body is the average kinetic energy of the atoms, it is safe to say that less momentum, less velocity, less kinetic energy, so lower temperature. So here we use six lasers in the six directions. It makes sure that all the atoms should be slowed down, but still there is a chance of leak out. So we use magnet optic trap, which is shown here. These process two coils are used to produce magnetic field, which gives the atoms at the center of the laser beam setup. Then evaporative cooling. This process is administered because laser cooling cannot achieve the desired temperature. Atoms can be cooled by two methods, depends on the type of trap. First, the magnetic trap, which we already discussed previously, but here slightly different. Radio frequency tubes are used to selectively expel atoms with highly velocity atoms from the trap. In optical trap, the depth of the trap is gradually reduced so that most energetic atom can escape the edges of the trap. The figure shown here is the optical trap. So here more energetic atoms are eradicated from the trap, and also the population of the trap decreases, and if this in turn decreases the energy of the trap and temperature of the trap decreases ultimately. Then determination of Bose temperature. The average number of bosons in the energy state E is 1 by e to the power beta and E minus mu. Mu is chemical potential minus 1. The total number of bosons in allowed states having momentum between P and P plus P between P and P plus dp is n is equal to P by 2 pi square h dot cube integration over 0 to infinity 1 by e to the beta E minus mu minus 1 P square dp. For ideal gas, E is equal to P square by 2m, again beta is equal to 1 by kT. So at a Bose temperature, the chemical potential becomes 0. So n becomes P by 2 pi square h square cube integrated over 0 to infinity 1 by e to the P square by 2m kTb minus 1 P square dp. From above equation, we get the Bose temperature is Dp is equal to 2 pi h square by mk into n by 2.612 P to the power 2 by 3. The experimental image of atom cloud. The first image shows that the density loss in the optical molasses set up due to atomic Brownian motion. This is the reason why trapping is necessary. The second figure shows the onset of trapping, and the third figure shows the increase in density due to increased trapping potential, and the fourth figure shows the atoms trapped in MOT, magnetic octave trap, and here the then the second fifth picture shows that the phase of vapor decaying and phase two. Then phase two, and BEC phase transited to 220 nanokelvin, and then the pure BEC is obtained. In correlation to the counter-intensive phenomena, first is Bosenova, first is basic Bosenova. A Bosenova, also known as Bose supernova, which is supernova like explosion that may be created in a Bose-Einstein condensate by modifying the magnetic field, which is situated causing the BEC quantum, causing the BEC quantum wave self interaction to become attractive. Uh, so when we turn the self interaction of the BEC from repulsive to attractive, they clumps together and suddenly disappears from the microscope. We can't detect them. So this behavior, scientists believe that this behavior of BEC as a Bose might provide information on the behavior of neutron star pulsar or as well as quantum theory in general. When superfluids have the fluids with the ability to flow in zero velocity. The first superfluid is discovered is the helium 4, and it was understood that superfluid is observed due to particle Bose Einstein condensation. It can be explained by the fact that BCs are effectively spore atoms, and all atoms of them move in the same direction with the very internal frictions. And superconductivity, superconductors are those which carry electricity without any loss of energy. When two BCS or BC are overlapping, and a process called photoemission spectroscopy is used to observe the electron behavior, it can be seen that these can exhibit superconductivity as well. Slow or stationary light. We know that the speed of the light is constant and it is c. But however, a scientist named Lennehouse slowed down the light from 3 lakh meter per second to 70 meter per second, and consequently stop the pulse within BEC. We know that light is made up of the reason behind it is that the light is made of photons. When they interact with the atoms, they form a hybrid subatom particles known as polar atoms. These hybrid particles are greater in mass, resulting in speed of their propagation decreasing. Then applications first detectors, detectors for rotation, gravity gradient, and acceleration use wave-like property of atom to do interference and measure minute shift in this effect. As you know, each gave a single atom which can be represented by a single application. This property make it more suitable for this purpose. Cognizance. One of the biggest problem of quantum mechanics and particle physics in general is that they are very counterintuitive and contradict Newtonian physics, so it is very difficult to visualize them. We shipping superatoms provide us with a substance that act like an atom but with a volume that is observably by naked eye. Then atomic lasers. When this is crafted into beam, it acts similar to a laser. Their property of coherence ensure that every part of the beam is identical or behaves in the same way. These lasers are much more precise and also relatively higher energy level as compared to normal lasers. BEC lasers are expected to revolutionize atomic physics and have a positive impact on fields such as atomic optics, interferometry, lithography, and holography, etc. Then using conclusion, BEC has provided a broad spectrum of research and applications. The application of BEC in superfluidity has opened the door to the future of microphysics. The idea of superfluids, when extended to superconductors, bring out promising results such as supermagnet and magnetically levitated trains. The implementation of BEC in quantum realm might lead to invention of most precise atomic clocks, more efficient quantum computing. The slowing and stopping of light by how has welcomed us to the future of optical storage of data and optical communication. So, human and humanity have tailored things that too good to be true, and total manipulation of this peculiar matter would be a miracle.